we're going to try recording something here. And to start off, we're going to verify your email to unlock your Leetcode. Successfully signed in. I guess you gotta do some email nonsense here. Leetcode, confirm email address. Confirm instantly. Page not found. High quality software. Alright. Sorry, but we can't find the page you're looking for. Guess we'll click on... Is that the same link? What the fuck? Alright. I'm gonna send the confirmation email again. We're just going to pretend like we are confirmed to start problem number 1. Problem number 1, to sum. All right, I don't know what this is. Code C++, Java. Is there Rust? There is Rust. What else do we have? We don't have any zig it looks like. We're going to try some Rust. So given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. So assumption there is that the is a word that sneaks in an assumption about existence and uniqueness. So there can only be one possible pair of indices, and supposedly the order wouldn't matter. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, that's fair enough. You can return the answer in any order. So, for example, if we're looking for a target of 9 with this list of numbers, we can output 0 and 1 because 2 plus 7 equals 9. Alright, that seems easy enough. Do we even bother? I guess, why do we have an impl here? Let's do... How many problems are there on Leetcode? Guessing probably a couple hundred. We're not doing a couple hundred. I guess if at any point we use more than 3. What is this called? This problem is called to sum. And my LSP isn't properly set up, so we will see how well we can do with that. How do I turn my preferences? Where is this thing? What is this thing even called? Is the show menu bar? Don't show the menu bar. Why do we still have the menu bar? View, show menu bar, don't show menu bar. Okay, so you have an array. And we have a target. The naive way to do this is to go over all possible combination pairs and take their sum. Generally, that's going to be an n-squared algorithm. It's not so good with long lists. Do we care about Leetcode? N-squared seems like probably, if it gets to be that point, it's probably too much. We don't care about this. This is a stupid problem. We're going to just do the naive thing for x in nums.iter copied for y in we're going to do pairs and enumerate over them. We are going to say if x plus y is the target and I is not equal to j, return, and it's allocating I in j. And in this case, we can panic. No such solution. Is that what we want to do if, so again, this is the assumption, can you come, takes less than O of n squared time complexity. Only one valid answer exists, constraints, okay. That's going to give us a constraint on the size of things. 10 to the 9th, what is 10 to the 9th? We're just going to assume we don't care. Numbers can be negative, the length is whatever. Well, we're going to do this first. We're going to just make sure that this solution works at all. Why are they? Okay. Okay, can you come up with a solution that's less than O of n squared? I'm pretty sure that this is where the actual algorithm gets to be a little tricky. What would you do in order to make this efficient? You want to find a pair of indices. You'd probably want to sort the numbers would be n log n. I don't care enough. We're just going to go on to the next question. Add two numbers. You are given two non-empty linked lists representing two non-negative integers. What? Two non-empty linked lists representing two non-negative integers. What does that mean? The digits are stored. The digits are stored in reverse order. What's the forward order? The digits, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. For example, 2, 4, 3, 5, 6, 4, and the output should be 807. So we're storing this in like a little Endian fashion. Okay, that's kind of strange. Is this problem number 1? Problem number 2? Okay. Kind of a monster uses two space in Rust. Okay, so I should probably make this a cargo project. So we will do that, and we will do is that valid? Yeah, that looks right. Okay, so impulse solution. This is so obnoxious. Like, put some boilerplate, but doesn't put everything. I guess we can just do this. Guess we can, there can only be one lib, can't there? I guess I have to add a main. We'll get that figured out. Okay, consider returning one of the two bindings. No, that's not what we want to do. We want to, why is that inline? Why is this all screwed up? Go. Looks terrible. But there we go. We got the correct number of spaces and things. So list node. So we've got an option box list node with a val. What we can do is write a method, a function called value, and that's going to take a node box list node, make it an option box list node, I guess, and it will return a value for it. And what this is going to do is if match node. So if it's empty, we're going to return 0, and if it's some head, no, some node, we're shadowing the variables here. We don't really care for shadowing the variables. And it's little endian, so the next one is 10 times recursive call plus the node.val, I think, is what we want. And so we're going to do node.next. And this is going to be 2 value, and then we can have a from value. And what does this look like is, again, it's little endian. These are little endian, right? Yeah, so that makes it easier because we just need to do digit, we'll say head is going to be equal to I, yeah, it's going to be value mod 10, and then we say let tail is going to be value div 10. That should be correct. And so what we're going to do then is if head equals 0 and tail is 0, and return none, else we are going to create a new node. And we are going to put in the head, and then this is going to be the recursive call from value of tail. Can't find value here. To value. Okay. So add two numbers is going to be a matter of L1 to value L1 plus to value L2 from value. And I think that works. It's guaranteed that the list represents a number, does not have leading zeros. Do not care about the corner case right now. What is this nonsense? Okay. All right, so we're going to get rid of add two numbers here. Just put, I guess, the solution there. Why are there all these? Is this because what is this? And then we have these two functions, which we will just copy. This is so obnoxious that you have to like painstakingly copy and paste stuff, and apparently it doesn't want to come through for some reason. I don't know if that's because of what I'm doing in Vim. Can I just open up like gedit? Something screwed up with my Vim configuration. Whatever. Cat. There we go. Maybe that'll work. Wrong answer. Okay. Output 0. That's bullshit. Those are... It is guaranteed that the list represents a number that does not have leading zeros. What is this if it's not a leading zero? Bull crummies. Except the number 0 itself. Okay, that's fine. I think in that case we will that does make it more difficult and like needlessly so. Because it just screws up the recursion in a way that it doesn't need to. I mean, we can special case it that if head is tail is 0, it's not going to be as elegant as it needs to be. But yeah, that's going to be weird. Oh, I guess if it's 0, then we return none there. I don't think that's going to be exactly correct. Wrong answer, because sometimes, yeah, that's what I thought. So the obnoxious thing here is that we need to keep track of the number of digits, because we have like this synthetic digit issue going on here where, I mean, add two numbers, if they do add to, these are always going to be positive values, I guess. I kind of wrote this assuming, yeah, the number of the nodes in each, the number of nodes is always less than 100 digit. It's guaranteed that the list does not have any zeros. There's no, okay, so there's no negative numbers involved here. So, this is also going to be the kind of thing where, again, like, you could get picky about the runtime of the thing, because you can do this more efficiently than the recursion that I'm doing here. Because it is in the, maybe we can actually use that to our advantage here. Sometimes I do this and I don't know why this thing is broken. Nope. Okay, so if all we're going to do is be adding these numbers, then in general they're going to be two different sizes. We're going to just add digit by digit. We can do this. We can do this better. Okay, let's try again. We're not going to do the naive recursion thing. What we're going to do is just go ahead and rename these A and B. Why are they options? I guess the options are fine for what we want to do. Let digit A equals A dot unwrap or default. I can't do that. Dot map node and node dot val dot unwrap, or I want to do unwrap or 0. So we have digits A and digit B. Let digit R equals digit A plus digit B mod 10. Let carry is equal to is greater than or equal to 10. There we go. So we've got our digit and then our carry. The problem is we don't have we don't have an extra parameter to forward the carry. We're gonna have to use a helper function anyway. Add what am I doing? Trying to do this recursively. Kind of do this where these are mutable. Just making sure that I can edit the problem in that way. Looks good. So let mute our. Why does it return an option? That's so dumb. This shouldn't return an option. This is dumb beyond belief. Why would I have a return of an option on this? If the option is not distinct from 0, but it's going to nip me on returning 0, that's stupid. Okay. Given a string s, find the length of the longest substring without duplicate characters. Without any duplicate characters. Again, these kinds of questions are like underspecified in how they want to be answered, because the easiest thing to do would be just use a simple hash set on these, I think. Maybe not. Maybe this is a little bit more tricky. Longest substring without duplicate characters. Longest substring. I feel like you'd use a vecdeck for this, where you push things on as long as it's good, and as soon as it's not good, you have to pop. So let's say we have let mutt q equals what did I call this? Not a deck. Is it a deck? vecdeck. That's what it's called. No. So we're also going to make this mutable. And you don't really care what the total length of these, or what the final string is on this, or the ordering. So what we can do is s.pop. I think s.pop exists. Should give me an option char. I'm going to do q.push s.pop.unwrap. Push back. So we're going to push the first element, and then how are we going to play this game? Is that, how do we know if it's in good standing? Maybe this is where we need to use a let mut. Hash set. And so, what are we going to do? While let sum char equals s.pop, and then eventually it's going to be q.len is the final result. So if h dot contains char, I guess I don't even really need the q, do I? And just use the hash set directly. So while if h contains the character, no, I do need the q. I do. The order is important. If the I do, because they're just a simple constructive example of where that difference would come from. Would be A, B, C, B, A, and A, B, B, C. Containing no duplicate characters. This has a run of 3. This one doesn't matter if you start here, if you start here, or if you start here. All of these are invalid, so the longest run you have is actually a run of 2. So the order matters. That's why we need to use the vecdeck. If the so if the set that's currently inside the vecdeck contains that, we have to while it contains that, we want to do q.pop front. We're going to unwrap that and then remove. We're going to do h.remove char. So what does this look like? After that, we know that h does not contain the characters. We just remove stuff until, and I'm pretty sure that's always the case, that this loop will eventually reduce the list so that it has no more duplicates in it, and then it stops. And then you can do h dot insert char. q.pushback char. And this is going to give me the wrong result because this actually gives me the final length, which in this case would only be 2. But we want to keep the longest, so we can do let mut result equals 0. Oh no, it's always got to be 1. Do result. And then here, result equals result dot max q dot len. And what is this going to be? This is going to be ni32 for some reason. Try into dot unwrap. So what do we got? We're going to see length of longest substring for A. Should be 1. Get our base cases in there. Gonna do AB, should be 2. Should be ABB, should also be 2. BAB should also be 2. Why does this take a string? I guess it needs to because of the way that I wrote it, but still. Okay, and then what's our example? A, B, C, B, A. B, C, B, A. And I think we said that that was 3. Okay, sure, why not? Give it a try, see if this works. Oh, that actually worked. Undeclared use of hash set. Dumb. All right. Call that a success. What do we want to call this? Problem 003? Medium of 2 sorted arrays. Does that sound fun? It doesn't sound fun. But given 2 sorted arrays of 2 different sizes, return the median, median mode. It's not the mode, it's not the most. Median means the number in the middle of the 2 sorted, what does median of the 2 sorted arrays even mean? Explanation. The merged array is that nums1 and nums2. So you're going to find the middle of these 2 things. So you want the middle. How is this a hard problem? This doesn't seem like a hard problem. This seems like it's not too bad. Let's take a look. Medium of 2 sorted arrays. So the important thing is that for a median, if the total two sorted arrays, okay, if the two arrays have an even number of elements total, then you just take the two middle numbers and average them together. We're gonna, what are we doing? We're gonna walk towards the middle of the array. We need to merge them first. Like, what are we even doing here? We're gonna merge, which means that we're gonna do let merged. It's gonna be a mutable vector with nums1.len plus nums2.len. And what we're going to do is we are going to keep pointers, indices that is, to each of these numbers, and we're going to fill in our list. This is going to be I, and this is going to be J. And the hard part is doing the merge. The merge is hard because you've got to deal with array out of bounds and that sort of thing. And it makes it really easy if we can assume that the values are all positive, but we can't. So I'm going to have both of those numbers point there. Oh, you know what? You know what would be an easier way to do this is if we did want to eat them as iterators. That way we can avoid using the indices. So if we do let nums1 iter equals nums1.into iter, and we do the same thing here. You have to kind of kick off the machine though. Are those going to be peekable? Is there like a peekable Rust peekable iterator? So what does peekable actually do? Peekable gives me a peekable of self. Creates an iterator which can be used, which can use the peek and peek mute methods to look at the next element of the iterator without consuming it. Cool, I like it. Thank you, Rust, for having exactly what I always want. And this is the peek method is should be option valued, I think. Yeah, okay. So I guess we can just do this. So if we peek both of them and they are none, then we still need to do let I equals I. at this point we can break whatever we're doing. We're in some kind of a loop that'll eventually get hit, so we can just make it a loop. If it's sum a none, then what we're going to do is merged I equals a I plus equals 1, or what can we do, nums 1 iter dot next dot unwrap, I guess. And we're going to do something similar over here, where if it's sum on the other side of this, we'll do sum A, sum B. Guess we don't really need to name that. And then finally, there's the case where we get sum A, sum B. And then we have to say if A is less than or equal to B, then we're going to do that on the one side. Otherwise, we'll do it on the other side. This actually needed to be a 1 up, 2 up here. And I think that should be enough to get us started. We can say merged. We've got our little merge function. So what does that look like back? 1, 3, 7, 9, back 2, 4, 7, 8. I don't want to do this I at all because I reserved capacity. We just want to do a push. Okay, that looks good. Now, once we have that, we can just do something as simple as led mid equals merged dot len divided by 2. And if mid is even, then we need to take 2. If mid is odd, this is the easier case, I feel like, is merged mid dot try into dot unwrap. We use a 64-bit float, but we only use a merged. F64 try from. Alright, so we're going to do low mid plus high mid. It just reads a little bit better. High mod, mid. And we're going to try it. Wrong answer. Am I off by one? This is in fact the example that I threw together. So the answer here should be 2.5. Why does that not work? Let's even try it. Just run our experiment very cheaply. So it might be the case that it would be easy to wonder, well, why don't you check this before running it? And it's like, because the experiment is free to run, it's just easier. Why would you worry about whether or not your analysis is correct if you could just run the darn thing? So the merge seems to be working, and then what do we actually get for the answer then? We get the length is 4. Is 4. So that means that the midpoint is 2. 0, 1, 2. Oh, length is 4. Length is 4. You cut it in half. Oh, do I just need to subtract 1 from the midpoint here? This is the kind of thing where if I put in, if I had a 0 length list, there's like no elements. The midpoint is like undefined. I mean, it's not undefined. It's -1 because there is no midpoint. But for anything else, if you have 1 here, you're going to take that 1, you're going to divide it by 2 to get 0, and then you subtract 1. Why am I not thinking of this straight? You want to divide 0, 1, 2, 3. You take that, that's going to be the first element. When you divide the length by 2, you're going to get the first element, the index of the element that starts the second half. When you have this degenerate case of just 1, that creates an issue too, because you don't have a second half. So, but in that case it's dumb anyway, because our total, like this obnoxious corner case that you got to deal with where there's only 1 element, but it can be in either one of the lists. The merge is going to work just the same, but I mean, we could put our base cases here just as well. I think this should work. I mean, this is real ugly. I don't like having code that looks like this, because you've got the 2 different exit paths. But that's fine. That's fine. And what does this actually look like? Result equals debug result. I don't know if I got this right. I'm not 100% confident I got it how I want it, but we're going to try it because it's just easier to run the experiment than to double check the work. And what do we get? What is this? Impulse solution or some nonsense like that. Okay, so I'm pretty sure 132. My merged, I'm guessing, is probably correct on this. It'll be 132 or 123. 132. Okay, 123, and then the problem is that I'm like totally screwing up on this. There's not just one midpoint. There's 3. 3 divided by 2 is 1 minus 1. Three elements. The midpoint is 1. I think the issue here is that I should be subtracting in this case if it's even. We're gonna just go ahead and give that a try. And we got our acceptance. All right, good enough. Well, not quite. I do want to say line 28. We'll get rid of that debug statement. We're gonna do a fun merge. Thumbs 1 back. Well, we're just gonna take the signature here. We're gonna turn that into a vec of I32, and we're gonna take all of this logic here. Put it here instead. And we're going to set this equal to merge of nums1, nums2. Get rid of that. Get rid of the mute. There we go. Much nicer. We will call that one done. What is the second one called again? To median. Median of two sorted arrays. I want to add anything else here? Was this one actually problem 0? Problem 1. Move that to src001 to some.rs. And we got some Leetcode. I guess we'll end it there for right now.